Hi, everybody. Hi. My name's Matt. I'm a software consultant and developer at Atomic Object in Ann Arbor, Michigan. We also have an office in Grand Rapids. Today, I'm not going to talk to you about something I'm doing at work at all. In fact, I'm touring like a JavaScript talk right now, which is like all about the projects I'm doing at work, and it's really heavy, and there's lots of architectural diagrams. This is all fun stuff I've done, and just some cool stuff I've discovered along the way. If you want to follow along during this talk, there's going to be some code up here, and I'm going to like put arrows at different things. You don't have to like remember any of it, but if you want to follow along, this is all in this repository, because I'm going to talk about this program specifically. So if you have a laptop and you want to check that out, you can follow along, or catch the video later. So what I'm going to talk about today is a program I wrote because I am a big fan of the social network Mastodon. Any Mastodon users in the house? Just Craig. Oh, more, yes. All right. This is great. So if you're familiar with Twitter, you know a little bit about how Mastodon operates. People post toots, they're called, instead of tweets. And they roll across on a live timeline, and you can interact with them, reply to them in a kind of a Twitter-like fashion. Mastodon's open source, and you can like have different instances that all communicate with each other. But what drove me to work on this particular project was a friend of mine likes to post music, right? And she'll post like YouTube links. You can click on each one of them, opens the YouTube tab, the music starts playing. You wait for the music to finish. You stop YouTube from trying to play something else, and then you go click on the next one. And I'm like, hey, this is really cool, because she's got really good taste. And I thought, man, but it's so much of a pain in the butt to click on these links. Wait a minute, I'm a software developer. I can fix this. So I spent a weekend in the Matrix and experimenting and relearning how threading works, because I've been doing JavaScript for so long I forgot how. And I came out with something like this. There's a little program I called it Stream at the time. It's part of a project called Fediplay. Mastodon is on the Fediverse. Fediplay, get it? Okay, and I'm sorry. But what this does is it will watch your timeline for all the posts that come from the people you follow. And if they post something with the hashtag Fediplay, and they post something with a link that YouTube DL, which is a program that's written in Python, also has a library that can download things from Bandcamp, from YouTube, from SoundCloud, it will download it to your disk and play it for you. And it'll queue them up as they come in. So as long as people are posting faster than they can play, you got a nice stream of music. You never have to go stop anything. So this was an experiment. I was a good little Python developer. I had a virtual environment on my Mac for it, and it worked for me, right? And I'm like, I want to share this, right? I wanted to share it. It's not like a graphical program, but I wanted to share it with at least people who are comfortable with the command line, but not necessarily Python developers. And that was key because there were a lot of dependencies in this. And so the very first thing I thought about doing was a standalone script. And I've done a lot of Python programs that I've distributed as standalone scripts. And that's great if you use the standard library, because then you can just give them one file and they can run it, and it's relatively certain it's going to work. I could not use a standalone script. This was my requirement set text by the time things were up and running. And I'm thinking, hey, this is a little bit too much, and I don't really want to try to cram this stuff into a file. So I thought about how else I could do it. I could ask people to globally install dependencies. And anybody who's developed, no, yeah, exactly. Exactly, yeah. Like,
I'll hate you later.
Yeah, exactly, yeah. I'd hate that. So that was out. Yeah, no problem there. I could explain to them how to do virtual environments. And this is another problem, because if you're a Python developer, you have virtual environment tools. This is great. If you're not a Python developer, this is a big mess of how do I set this up? How do I do this? How do I do that? And I got to give props to, there's a project called Algo, which like sets up a VPN for you in the cloud. And they actually try to explain how to do virtual environments in their README. And I'm like, you guys are so brave. I didn't follow their directions either. I did look at PyInstaller a little bit, because I thought, hey, maybe I could build some binaries out of my script. PyInstaller will take your Python script, all your dependencies, bundle them up into something that can be executed on different platforms. But then I thought about, oh my gosh, now I have to have different platforms that are going to build different things. And I really want to go home and build Lego Voltron, and I don't have time for this, right? I just want to share my code, all right? So I was frustrated. I was like, okay, how do I do this? Because I love virtualenvs, but I really, how do I do this? So I went digging, and I discovered a project called Pipenv. And a few of you are nodding along. You've already discovered this religion. This is great. But this really turned out to be a great tool for not only helping people who weren't Python developers run my code, but also helping people who were Python developers contribute to the code really easily. So getting started with Pipenv, well, look at all that stuff, man. Oh my gosh. We don't care about the stuff that's small, but that's just stuff that it's going to print out. So I want to show you 3 things here. This is starting a new Pipenv project. As long as you've got Pipenv installed, which there's directions on the website on how to do that, you just make a directory, change into the directory, and do pipenv, and tell it which version of Python you want to use. And this is key. You can do 2 or 3 if you're still writing a Python 2 project for some reason in 2018. I'm sorry. And so let's talk a little bit about what just happened here. The first thing it did is it looked in your path for Python 3. It can also look in, if you have Pipenv, which I highly recommend, and to like manage different installations of Python on a Unix system. It can also look in that. I discovered very recently it uses, I'm not super familiar with the Windows Python ecosystem, but there's something called Py, which can also manage different Python environments, and it found it on my system. I didn't even know it was there, and it used that to locate Python 3, which I thought, it's pretty cool. So it looks for Python 3. It creates a virtual environment for you. No more interaction, no more creating it, no more, no installing anything else. It all comes with Pipenv. It creates something called a pip file. And this is, we're going to look at the pip file a little bit, but the first thing it's going to do is it's going to lock in that version of Python 3 that it found. And specifically the minor version. So in my case, it found 3.7. And as you can see down there, it says, OK, this project is going to run on Python 3.7. If somebody comes along and tries to pull in a different version, they'll go, oh, hang on. This guy wrote this for 3.7. You might have some trouble here. So you're going to have to do some extra steps if you're going to try to force it to run on something else. So once we've got this thing started up, we want to get in and start working, right? So there's a command called pipenv shell. And what this does is it starts a subshell and activates the virtual environment right there so that you can get in. Now you're in, right? Now you're ready. You're all set to go. Anything you issue here now is working inside your virtual environment, isolating all your dependencies from everything else on your system. So fantastic. Creating reproducible environments. There you are right there. So let's add some packages. Spoiler, I'm going to talk about Click today. But Click is the first thing we're going to try here. And what we do is we just type pipenv install and the name of the package we want. And then it goes through, does all this stuff. What just happened here? You looked up Click on PyPI, right? Downloaded and installed it into our virtual environment for us, so it's ready to use. Added Click to the pip file. This is a little different from the pip workflow where it just records the package and you can do a freeze and you can dump it, or you can manually work with your requirements.txt. This is automatically dealing with this for you, which already is a huge, huge advantage. And it records all the installed packages that it brought in, and their versions and hashes to pipfile.lock so that your exact setup can be reproduced anytime somebody else wants to set it up. It added just this one line. Because I didn't ask for a version, it says, hey, any version of Click will do. I could ask for a version if I wanted. I can edit this after the fact to say I want specifically version 6.7, which is the current one. I'm pretty confident Click's not going to break. I don't know if that confidence is misplaced or not, but this is a music player for a social network. I think it's OK if it does a little bit. So once we've got those files, we commit them to source control, right? We just add the pip file and the pipfile.lock, and we are actually all done creating a project that will allow people to run it. So now somebody else comes along, wants to run our program. How do they do it? Clone our repository, gives them a directory called project here, OK? And they just run pipenv install with no other parameters. Goes through, does all kinds of stuff. Gives them some nice friendly instructions at the bottom how to use their pipenv, and we'll cover those in a minute. But Those last two lines are nice and friendly for people who may not be familiar with Pipenv yet. Well, let's talk about what happened over here. First thing it is, look in their path for a Python 3, an incompatible one. We asked for 3.7. It's going to want 3.7, right? I actually tested this just this morning because someone came up with a question, what if you have 3.6 and don't have 3.7? The answer is it'll say, you don't have 3.7, so you're going to have to force me to use 3.6 if you really want me to use 3.6. So in my case, that probably means that my pip file shouldn't say 3.7 because I'm not using any 3.7 features. But creates a virtual environment for them, uses the pip file to determine what packages to install, uses the lock file to check the integrity of all those packages that we got and the versions we expect. Then they can type pipenv shell, and they're in. And everybody else who clones your repository has the same experience. This is great. They can all listen to the music. I can take a 3 or 4 month nap while I don't have to deal with anybody with the wrong package versions or anything like that. But while I'm sleeping, I'm thinking, hey, what else can we do to this project? Because it's a pretty simple project right now. And of course, there's a bunch of weaknesses, and I thought, hey, I can make this better. So what could I do? One of the things I thought of pretty early on was the ability to add more commands. People were pasting links into their toots on Mastodon, which didn't necessarily actually play, and kind of surprised them sometimes. So I thought, hey, a test command might be nice. So they could put a URL in there, see whether the program's actually capable of playing it before they post it. Save that horrible, horrible embarrassment, right? Add filtering options. I follow probably 300 some people. Maybe 20 of them are active. I don't know. But sometimes they're playing music at the same time, and it creates kind of a mess. I'd like to just filter that to one person. That's a PR that's in process right now. Somebody else actually is contributing to that. At some point, I got to actually approve their PR. And then just a couple little cleanup things. The API keys for Mastodon, I was just saving them in the current directory because this is a hack, right? It didn't matter. I would like to stop dumping music files in the current directory because, man, there were quite a few of them after you run it for a while. So that would have been nice to put them someplace out of the way. And finally, protecting the API keys. Yeah, these are API keys for accessing a social network. And you can argue that it's a little bit lower of a bar than, say, AWS keys. But I think users expect us to treat their secrets with care. So I wanted to see what I could do to improve that situation. So let's talk about improving the interface first. The main thing I wanted to do is let the user change the program's behavior in different ways, like do the test mode, maybe go to debug mode to look for some messages. We had to debug some YouTube DL interactions at some point. So I went through and thought about my options. Now, I have been developing Python for a couple decades now, and this was before a lot of the argument parsing libraries had even come out. And the very first one I used was getopt. And man, this looks like a lot of fun to do right here. This is just for a debug flag, right? Right? And so this lets somebody say -d or --debug, and it turns on debug mode, and we can print a message. And I'm like, yeah, this is OK for 1 or 2 options, but this really gets out of control fast when we start talking about intersections of different options and different commands and that sort of thing. Debug mode makes a lot of sense everywhere, but maybe not. So these days, if you're going to go to the standard library, you have argument parser, which is better. But it's still like we have to build this parser, and then we get this object that has things on it that we have to check, and it doesn't support some of the really cool new features you see in a lot in command line applications. So I really wasn't thrilled with this either, because that was one of the things I thought we could do for test mode or whatever. I could add different flags. But then I thought, I don't really like that user interface because we're kind of changing the way the command line arguments are interpreted by having different flags that have different modes. And I'm like, this is really getting messy quickly. I could have split it off into different scripts. Personally, I just don't like having a program that installs 20 different programs. I'm sorry, I just don't like that kind of stuff. So what I really wanted was like Git does. Hey, we have Git checkout. Git clone, Git stash. It's all Git, but it has a subcommand, and each subcommand has its own options. And so I went and looked, and I was like, well, I could do this with argparse, but then I'm adding some more code up front. So I went looking, and I didn't have to look far because every other large Python command line program I looked at was already using click. And click has been around a little while. Of course, I had never used it until late last year, and I don't see myself using anything else from here on out. Click is amazingly simple to use. This is the top level of our program here, and we just decorate this function with click.group. Whenever the CLI function is called, it kicks over into click. It does all the argument parsing for us, and it just kicks over into a click program. This little line right here, ensure ders, is a function I wrote to make sure that directories that the program needs are created before anything else runs. So this is kind of like a way to just kind of have a hook that some code will run before anything else runs. It's like some initialization, because everything flows down from here. Now we're going to start adding some subcommands to it. This one is the stream subcommand. It's kind of the main one. And we decorate it with the CLI function that we have is now a click function. So it has decorators on it. In this case, the command one says this is going to be a subcommand of CLI. And it has arguments, which are very important. And in this case, one called instance, which we're just going to pass straight through. It's not a flag. It's not anything like that. It's just going to pull something off the command line and feed it right into this function. So how this works now is if somebody comes along and just executes the program, they get help like that. It's just automatically built from everything. This line right here, if you notice the doc strings, those are just taken straight across and used in the help function. So write those so they make sense to users. But you don't have to like specify the help for different commands, in different structures and that sort of thing. It's all. What I really love about click is it really kind of takes the Pythonic structure of a program and uses it to inform how the command line interface is constructed. And similarly, there was a doc string on stream, and that's used for that subcommand. Stream has its own help, right? And it knows that we have an argument called instance, and there's that doc string again, right? So it's really very discoverable. It's all constructed from really, really simple code and just a couple decorators. It's pretty fantastic stuff. I learned a couple lessons about structuring my click program when I was doing this. The biggest thing this is my recommendation if you're going to build a program like this. Put everything in one package. This is kind of the recommendation for building out a Python package inside a source repository anyway. A package being a directory with a dunder init.py file in it. And inside that, you want to import the function that was the top level of your click program. And that looks like this. And that will be important in a minute. The next thing is, I didn't even know this existed until late last year. I've been a Python programmer for 2 years. This dunder main.py, I had no idea. I just discovered this. You're still learning, right? Forever. This is, if somebody does python-m with your package name, then you can, then it will actually execute this like it was a script. And so we put this in there, imports it again, and just calls it. So this is like one way for people now to run our script. Yeah, and there's that call right there. Remember, anytime you call CLI, you go right into the click interface. In setup.py, we're going to create a script for package CLI. And that looks like this. This console scripts line is really important for cross-platform development. Here what we're saying is, I want you to create a program called fediplay. On Windows, it'll create an exe. On Mac OS and Linux, it'll create a shell script. I think it's a shell script. Anyway, it's executable. And what we're telling it to do is I want you to pull the module package fediplay open and call the CLI function inside it, right? So that will create a program that knows how to get into your code and run it. One more step, which I found is really actually kind of cool. I actually want that script to install into the virtual environment when somebody comes along and types pipenv install. So I use a little trick from pip called the editable installation, where you install something with a -e dot. And what that's telling pip underneath pipenv to do is we want to set up a development environment that from the current directory. So any packages in there will be treated as if they were a package installed. What that allows us to do is, whenever we're inside that environment, we do import fetaplay. It will pull that package from that root directory. And any scripts we install will be available to execute. So as soon as we're inside that shell, we can just type fetaplay and it works. Or if we don't even want to get into the pipenv, we can do pipenv run fetaplay, which will go into the virtual environment, call fetaplay, and come right back out, one command. One really awesome trick, once you've got this set up like this, if you want to, you can go and do a symlink from that whole line there, which is where that virtual environment is. And there's a pipenv command to tell you where that is. You don't have to go find it on your own. And I just put it in my local bin directory, and now I can execute it from anywhere. I don't have to change directories anywhere. I don't have to start up virtual environments or anything. It's just there, and it just works. So that is how I do that structuring. And I encourage you to take a look at that Git repository when you're building your own command line applications, because I dug out a lot of lessons from a number of different tools to get there. And I think that's one of the great things about open source is you can go dig and see how other people did it and do it yourself, right? So the next thing I wanted to tackle is where to keep the files. As you remember, I was dumping everything into the current directory. And that means I'm not a good citizen of my operating system. Operating systems have features for this, actually. The problem is on Mac OS it's here, on Windows it's here, on Linux it's here. Which one do I use, right? And I'm like, okay, I could write some logic for this. I really don't want to. Somebody must have done this already. And especially when I start talking about cache directories, because these are for storing configuration. I also am just downloading music files, and I'd like to keep them in a place where they're around in case somebody needs them in the future, so they don't have to re-download them. But I also want the operating system to kind of know, hey, this is an area where you can delete stuff if you're running out of space, right? So that gives the operating system the hint for that. And I went digging, and I was kind of surprised because not a lot of people, I asked this on Mastodon, actually, of the Python community there, and nobody had any idea if there's a module to do this for me. And so once again, I went digging into some other programs, and I found a little library called apters, which does exactly this. All I do is bring in this apters class, call it with 2 arguments, the name of my program and me. That's my handle there. And I create an object called dirs there, and then I can import that anywhere in my program, wherever I need a directory. And you actually already saw it when we looked at the stream function before. We just pull the cache dir in there and pass it into the stream function. And that tells the streamer where it can download all the files to and play them from. There's a number of things you can pull out of apters. Here it is on Mac OS, config dirs, cache dirs, log dirs. And if you're doing something that runs on the system, you've got the site functions, for all users. If you're working in, super user land. And, if you run the same thing on Windows, you get all these other directories here. And it's all constructed from what apters knows about different operating systems and of course, the data you gave it. One last thing, as I mentioned earlier, storing secrets. I consider this very important. I get irritated when I use an AWS command line tool and it just dumps a file somewhere in my home directory that stores these keys that could be used for somebody to convert the project I'm working on into a Bitcoin miner or something like that. I mean, I'm not in the habit of sharing those files around, but it just makes me a little nervous. I'm like, there's got to be something better, and there is. Users expect us to treat these secrets confidentially when we write programs that handle secrets. And previously we kept secrets in files readable only by the user, protected them a little bit. But we can actually do better. Operating systems have a concept called keyrings. And what these are is they're cryptographically secure storage, unlocked when the user logs in, and it firewalls programs from each other. So now in the case of this, in the case of a Python script, it firewalls it from anything that's not a Python script. But if you have a compiled program, then it will say, oh, well, this program put in a secret. I'm not going to let this program pull that same secret out. The operating system firewalls these off from each other. So there is, thankfully, a library for that. It's called, appropriately enough, KEYRING. I have one little note here because if you're on a Mac OS or a Windows system, the operating system keyring service is always available. It's just going to be there. On Linux, the story is a little bit fuzzier. And if you're on something like OpenBSD, which I, for fun, will just go and kick that in sometimes, the chances that a keyring service is available is just about 0. So this extra little package here is optional, and it will just create a little dot file and kind of lightly obscure it. It's not secure in any way, really, but it's better than crashing the program. So if you have a requirement to keep these secrets, don't include keyrings at all, and your program will actually stop working if it can't find a keyring service. So that's just a little, it's in the README for keyring, but I did include that here because it's an improvement. So just using the keyring module really quickly, it expects a couple different things. It expects a service name, which is the name of our program, and it expects a username. We store 3 different kinds of secrets in fediplay. There's a client ID and a client secret for the program itself on the server, and there's an access token for the user. So what I did is I created 3 different usernames. All they have to do is make sense to our program. So I just concatenate the word access token and the name of the instance. In my case, cyber.space is the one that I use. And then I just created some wrapper functions around this. Set password function will put it into the keyring. Over here, we have the get password function, pull it out. And then if I want to tell whether that credential exists or not, like if I'm doing first setup and I need to tell the user, hey, it's time to log in, because I don't actually have keys for you yet, I can do this little check here, because it'll return none if that particular secret is not in the keyring. So and that's that. Wrapping up, use Pipenv to manage your dependencies. Don't use anything else. OK. I know sometimes you don't have that option, but for this project, it's been great. I mean, apart from the ease of setup, the ease of contribution is fantastic, because anybody who's even just a lightly, just kind of a novice developer who knows a little bit of Python can go in and make changes and contribute them back without having to worry about setups or anything like that, because they can just go right in, change the code, try it again. Right? It's the perfect iteration loop there. Use click for your command line interface. I mean, I don't think there's any reason to go back and use those the standard library parsers at all anymore. The way it works is just so slick. And you can construct like arbitrarily complex stuff using click. Apters to figure out where to put stuff. Keyring to store your secrets. And hey, enjoy the music. Thank you.